Hello, everyone. Good morning, good afternoon. Let's welcome for today's APSCE webinar. So you're honored to have Professor Dagan Kasvik, one of the speakers. So the webinar titled Unlocking Potential, Leveraging Multimodal Learning Analytics for Collaborative Learning. It's my honor to introduce Professor Dagan Kasvik. Professor Dragan Kasvich is a distinguished professor of learning analytics and director of research in the Department of Human-Centered Computing of Faculty of Information Technology, and also the director of Center for Learning Analytics at Monash University. Dragan's research interests center around data analytics, artificial intelligence, and design methods that can advance understanding of self-regulated learning and collaborative learning. He is a founder and served as the president of Society for Learning Analytics Research, SOLAR, from 2015 to 2017. He has also held several honorary appointments in Asia, Australia, Europe, and North America. He is a recipient of Lifetime Member Award at 2022 as the highest distinction in the Society for Learning Analytics Research, SOLAR, and a distinguished member of ACM. In 2019 to 2022, he was recognized as the national field leader in educational technology in the Australian research magazine that is published annually. He has led several projects across the continent, in the European Union, in Canada, also in Australia. So let's welcome Professor Dragan Kasvich for the webinar today.
Thanks so much, Ram. I really am honored to be with you all today. I'm going to just take a moment to get started. My slides on my end. All right, so hopefully my slides can be now easily seen. All right, yes. So thanks so much for the honor of the invitation, also for the very kind introduction. I really appreciate to speak to this community, although I don't think I've ever participated in any of your conferences before. I've followed and read many of the papers that are published by the people in this community, so I'm feeling very welcome and also very connected with this group of people. So today I'm going to be talking about work that is related to the use of multimodal learning analytics for collaborative learning. It's the work that is done with many colleagues and collaborators in the Center for Learning Analytics at Monash. And I can't really just enumerate so quickly so many people who contribute to so many different ideas that I'm going to be talking today about. But you will see many different citations of the references that are explaining the original ideas. And by that extension, I'm going to be also acknowledging the contributions of the individuals that contributed to the work. I also would like to acknowledge the owners, the traditional owners of the land that I'm today in Melbourne, and that's basically the Kulin Nation. And I also like to pay my respects to their elders, past, present, and emerging. I'm going to be primarily talking about collaborative learning because I think many people already know why collaboration is so important. We understand that we live in much more complex world, and that world is becoming even more and more complex, not only because of the now 20-plus-year-old connectivity increased, but also because of the climate change, because of the security changes in the world, and also just simply the complexity that artificial intelligence is introducing to the world. So we need to be much better at collaborating to solve much more complex problems that the world is bringing onto us at this very present moment. So we also know from research and the literature that collaborative learning can be quite beneficial. It can enhance the sense of community. It can, in certain situations, be associated with the increase of creative potential of the individuals. And also many studies demonstrated the opportunities for the collaborative learning to enhance academic performance in certain situations. Obviously, collaborative learning is a very complex endeavor as well. And to get collaborative learning right in different types of contextual situations, it's really requiring us to understand a very complex interplay of many different factors that are shaping collaborative learning. So we obviously have some level of understanding of these different factors, but we really want to enhance the quality of collaboration in many settings. And to do so, then we are really interested in the understanding of the extent to which what type of data are needed for analysis and how we can then use that data analysis to potentially enhance collaborative learning in certain situations. So to do that, I'm going to be building on the definition of collaborative analytics that I had a pleasure to co-author with Roberto Martinez Mandolado, Simon Buckingham, Vanessa Echevarria, Gloria Fernandez Nieto, and Zach Zwicky. Most of them are now in our group at Monash. And we basically, when we are trying to think about collaboration analytics, we really typically start from the understanding that there's a group of people who are typically working together on a common task. That group can be collocated in a physical space, or that group can be also completely distributed geographically. The idea for us is then that we try to collect some low-level of data that are describing that collaboration. And we're going to be talking about different types of low-level data that can be collected, especially with the use of multimodal type of opportunities. The ultimate goal is then to produce some form of collaboration analytics. And that collaboration analytics typically is not just us doing very sophisticated applications of machine learning, but it's actually entail several key ingredients. I'm going to be mentioning here 3 of them. The first one is that we have to have a really good understanding of the task and the design that is involved into the really shaping that collaborative learning opportunity. The second one is that when we are even analyzing different types of data, that we have to have really good understanding of theory that is underpinning the constructs that we are trying to measure, and also the types of skills that we would like to promote as we are using collaborative analytics. And then, of course, equally so, we want to provide some feedback to our key stakeholders, educators, and learners. And to do so, we need to engage into human-centered design so that we can create very effective user interfaces and the type of visual and other types of analytics that can lead into something that we call actionable group insights. And these actionable groups insights are then eventually offered to the group of learners and or educators that are trying to enhance the overall learning experience and the outcomes. In today's talk, I'm going to try to see how that learning analytics loop can be implemented in collaboration analytics, but following a bit more simplified model that'll hopefully help us enhance our conversation today, and also that'll be based on a model that we defined a few years ago as well as a relatively simple model that offers us to really have easy communication of what kind of things people need to consider when they are engaging with learning analytics. So the core idea is that we will start from the understanding of the type of data that are potentially beneficial for collaboration analytics. Number 2 is that we need to think about different types of modeling approaches that are helping us to understand collaboration. And then obviously, these type of models are eventually leading into transformation of our practice that typically means the introduction of a certain analytic tool that has some form of a user interface based on which we can take certain actions. But obviously, this is a cycle that is repeating multiple times and leading in a form of a spiral of continual quality enhancement over times. So I also have a tendency to give away immediately some key takeaways that you can get from my talk. So if I get to bore you with certain things towards the end of my talk, or if you're not interested or don't have time to stay by the end, I want to just give you immediately what I think. First one is that really we cannot easily account for the complexity of collaboration in the physical spaces without the use of multimodal data. That's number one. And the number two is that we cannot produce effective analytics that can be conveying relevant messages and feedback to our key stakeholders without the deep engagement into human-centered approaches. So those are the key takeaway messages. And I'd also like to encourage you to have a look at the special issue that was edited by a really nice group of editors and colleagues and researchers in the learning analytics field that was published a couple of years ago in the Journal of Learning Analytics. So now I'm going to dive into the certain details with respect to the data. So when we're talking about data, I really want us always to step back and think about what is our theoretical lens for understanding of learning. Because only then we can really start thinking about what kind of data that is currently being collected could potentially be relevant for us. And even more importantly, when I'm trying to collect new types of data, how I can improve my instrumentation. And to do so, we typically can think about many different dimensions of collaboration. In lots of the work that we are doing, we typically theorize collaboration through two key dimensions: social dimension and cognitive dimension of collaboration. And I'm going to be using these two key dimensions as well as I'm explaining certain elements today with respect to the data, but also modeling and the transformation. So then the key thing is then when we are talking about multimodal learning analytics is to address the complexity of collaboration. I'd like us to think about one complex collaboration scenario. This is a photo taken by our team who is closely collaborating with our School of Nursing. These are the nurses who are requested to work as a team in a simulated healthcare scenario. In this simulated healthcare scenario, nurses are not dealing with the actual real human patients. They are dealing with mannequins. These mannequins basically are offering also certain opportunities for these nurses to operate on them, meaning that they can exhibit certain types of symptoms, and the nurses need to observe those symptoms, diagnose them, and eventually take action. However, inside of this environment as well, nurses can be required not only to collaborate with each other, but also with a doctor who is typically an actor or another nurse who is a part of the teaching team who is acting as a physician. On top of that, these collaborations can be disrupted sometimes by having an actor who is pretending to be a very abusive or very, in a way, uncollaborative family member of one of the patients. Typically, inside of these scenarios, we are trying to collect the data about the locations of our nurses so that we can understand how closely they are working with each other over time, how closely they are with different types of patients, because often we have one primary task inside of these simulations that is happening around only 1 out of 4 patients in the ward. And then there are other patients as well that need to be looked after. Then we also can collect the physiological data by different types of sensors like wristbands. We can also collect the data by just observing interactions because these mannequins as well collect the logs. Nurses almost always in these simulations wear mics because even if they are not doing learning analytics, they are requested to wear these mics because these collaborations are recorded that could be then eventually used for their debrief upon the completion of the collaboration. So this is what is happening inside of that space. So now thinking about what kind of sensors are typically used for collaboration analytics, broader and multimodal learning analytics, we see that majority of the studies, great majority, are typically using video, just the webcams, or audio types of sensors. Fewer studies are using different types of biometrics, like I mentioned, certain wristbands that can collect electrodermal data or heart rate variability and so on. Even fewer studies are looking into the movement. Not so many are actually looking into the eye tracking that could be actually done inside of this type of a physical environment. So when we collect this type of data, it's fine to talk about these types of sensors, but what kind of data or what kind of insight can we get? And if you go back to the definition that I indicated about collaboration that is shaped by two key dimensions, social and cognitive dimensions, then when we are talking about social dimensions, we are often talking also about social ties. And there's the whole field of social network analysis that is really looking into the extent to which social ties are really potent sources of influence. These sources of influence could be really effective on understanding the group cohesion. They can be very effective to understand the overall dynamic of a group that is working, but also quite predictive of the performance and the efficiency of a particular group. So now you may wonder, okay, we have these physical spaces, how we can actually get these social ties and how they can be identified. In most of the research that we've been doing, we are building on this theory of proxemics that is actually positing that there are certain sets of interpersonal distances that could be between people. So there is certain space that is very close to us, that is just our intimate space, something that is much more personal when somebody gets very close to us, something that is much more social space around us, something that means that we are actually interacting with these people, and then much more general public space around everybody. So in most of the cases in our research, we are actually able to get these social ties by the analysis of the indoor positioning data, meaning that each of our participants usually wears one of these location sensors. They can actually, POSIX sensors can be bought relatively cheaply for the room like this that I was explaining. They can actually, the whole system may cost less than 1,000 Australian dollars. And we can then, based on that, not only get the indoor positioning of the data, but we can even get basically the direction in which our participants are looking into, based on which we can determine the types of social interactions they might be looking into. And you can see here even just basically the location movements around one single patient by multiple nurses and individuals who participate in one of our simulations. Similarly, we also use these location sensors in one of the schools here in the greater Melbourne area. And this was a bit much more expensive system, which costs almost 50,000 Australian dollars. And it basically requires these, like the previous system, also fitting these general location sensors to be fitted into the, in this case, you can see the ceiling of the room. And then each day, each of our participants, in our case, it was about 100 students, and the teachers would be asked to get these sensors. So you can see that we've followed these students in the open spaces and the teachers. There was the period of 8 weeks. We had them for 101 sessions, and you can see we collected lots of data points, almost 175 million of data points over that period of time. Obviously, every day, these individuals had to put these little location sensors on them, which in terms of the ethics and transparency was a good exercise, because they were always in a way notified that they are getting this sensor, and that was done with this type of data collection. And you can see here, based on these type of data, we can then actually replay the movements of the students or the teachers in these type of spaces. Based on these type of data, then we, and following the theory of proxemics, we then decided to extract the data and to extract specifically the social ties of the learners. So how we theorized that there was a social tie between the learners or the teachers with the learners in that space is if we actually used proximity of at least 1 meter or less for the duration of at least 10 seconds. Otherwise, if that interaction lasted for a shorter period of time, then we would not be using that to extract the social ties. And you can see here, based on this type of data, we were able to establish the social networks. They were really very helpful to us to understand the social dynamics between different subjects that students were studying in that period of time when they were following different pedagogies. For example, kids for reading versus maths versus some other STEM subjects. And then we could see also how effectively or ineffectively certain teachers were using the space. And in this particular case, school was very proud that they got this new open space for them. So we obviously do not suggest in terms of the ethics that you always instrument your kids like this, but it could be really useful when you get a completely new space to use, and you can get that space to practice new pedagogies, to reflect on these type of pedagogies, enhance your pedagogies, enhance the configuration of your space and resources, and then basically let everybody to mind their own business without being continuously monitored. This is another example that I was talking about, which is our nursing simulation. And in this case, obviously, we collected these indoor position sensors. But on top of that, we also had this webcam, relatively inexpensive webcam, something in the range of less than $500. And the webcam, which would basically have this very broad angle of 180 degrees. And you can see that we could observe our nurses and how they are performing this particular task. Once the nurses were actually completing these tasks, we then actually turned them to see the extent to which computer vision could be helpful for us to extract some of these social ties between nurses. In particular, we were much more interested in understanding the extent to which learners were spending the time in particular areas of interest for our study. That is to say, the extent to which our learners were spending mostly around particular areas, like, for example, around the primary task, which is bed 4, secondary task, bed 1, or where there was a distraction around bed 3, where we had one of the relatives, the actors were pretending to be a very disruptive relative who was disturbing the nurses, and then also IV station and so on. Based on that, we deployed an algorithm based on tracking model that is used also for tracking people as well with some of these CCTV cameras and other spaces where people are moving. And also the extent to which, when we determine which of these areas or interests are, to also not only to identify where the learners were with respect to these spaces in any point in time, in every frame of our videos, but also this approach allowed us to completely anonymize our participants. So in a way, allow us to be privacy preserving in that sense. And this also proved to be very helpful in the representation of some form of social ties that are actually determined by the joint spaces in which people were participating, and also proved to be a fairly inexpensive approach to implement this type of analytics. I've so far spoken mostly about social dimensions of collaboration. When it comes down to cognitive dimensions of collaboration, that is typically done by really looking into the discourse. Obviously, in online environments, discourse comes from, online discussions, chats, many types of emails, etc. That could be derived. But then in the physical space, you really have to collect the speech of the people, analyze that audio for certain really verbal, but also sometimes even more verbal signs. In most of the cases, obviously, that is done to have a really good quality of the microphone. And we are actually learning some tough lessons in that space. One year, we actually bought fairly expensive microphones that were really not effective to be used in this type of physical space that is very dynamic. And in some other cases, we've then bought fairly affordable, again, microphones, set of 4 with relevant equipment behind the scene, etc., that costed less than 2,000 Australian dollars, I think even less than 1,000 Australian dollars, if my memory serves me well, to actually be able to collect good quality audio as they were going. Obviously, beyond thinking of social and cognitive dimensions, we can also think about other dimensions that are relevant to collaboration. Obviously, stress is quite relevant when it comes down to collaboration. And in many of the situations that we've been working with, we are trying to use these wristbands, but they are proving to be a really unreliable source. People are moving, and the moment that when people are moving, these also wristbands are moving. And then to measure the electrodermal activity of the people becomes highly unreliable. Often we even have to ask nurses to wear 2 of these wristbands, 1 on each hand, which is proving to be then very expensive because each of these wristbands costs almost $1,500 to $1,600 US. We are talking about Empatica E4 devices. And then often we lose most of this type of data. So it's a really kind of an interesting endeavor. It can potentially get us some interesting data, but at the same time, getting that data reliably collected is a difficult thing. So then the final thing to think about in this process is how to get from these multimodal data into the actual constructs. That's, to me, the most interesting and important part of the process. So this is the model that we showed in the paper that I previously mentioned. And it basically starts from the point of getting from the data that are really computationally detectable. So, for example, my physical movement, my location, utterances that I'm seeing, etc. Then, once I have collected these type of data, I need to think about what are those relevant indicators of certain constructs that I can get based on these type of data. For example, can I get an indicator based on the location, whether I'm working on a primary or secondary task that could be really then eventually indication as well, whether I'm working collaboratively or individually with somebody. Another indications could be also obtained from the speech, whether I'm actually asking somebody for some information or whether I'm sharing information with others, whether I'm acknowledging receipt of certain information. Those could be different types of indicators that could be then mapped onto the social or cognitive dimensions that eventually represent collaboration. This is just one example that many years ago, Roberto Martinez Mandolado used in his research, in which he actually theorized collaboration through transactivity and symmetry of actions. But then for both of these, he was looking into different types of behavioral, if you wish, markers. So with respect to the transactivity, he was really just looking for co-presence of ideas from 2 group members in a certain proposition of their speech. And to do that, he was looking into their artifacts. For example, he was looking whatever they were constructing as part of that collaboration. In terms of the symmetry, he was looking the extent to which individual verbal activity was basically aligned or symmetric to each other, or the extent to which physical activity was also symmetric. And to do that, he was then extracting data from speech or groupware logs, and then analyze it into forms of speech acts or touch events. So this is with respect to the data and what these type of multimodal analytics can be used to collect and the complexities that are surrounding multimodality in that process. When it comes down to collaboration analytics and the way how we can analyze these type of data, in most of cases, we are not thinking only about just blunt application of machine learning. Machine learning can be helpful for certain tasks, and I'm going to mention some of these along the way. But much more nuanced and interesting questions in collaboration are really often answered by the applications of social network analysis and epistemic network analysis, and in many cases as well by their combination. this is the piece of work that I collaborated on with David Schaefer, Srečko Joksimovic, and Brendan Egan a few years ago, in which we proposed this social and epistemic network signature, which is basically trying to understand how we can leverage these social ties and the discourse that is analyzed through some form of coding or content analysis, and then produce epistemic network analysis on one hand and social network analysis on the other hand. And that could really be an interesting approach to combine these two approaches. So I'm going to be talking about some of these things, how we are analyzing them, applying them, but also probably for the interest of time today, I'm going to be focusing mostly on the epistemic network analysis. So I'm going to be talking about three specific examples of the analytics. One of these analytics is the analytics, obviously, of social ties. And in many cases, obviously, analytics of social ties can be done through the use of social network analysis. I'm sure many people in this room also seen examples of that. When it comes down to the small group work, social network analysis may not be as effective as it could be on the large network sizes, although there are some people also in the Asia-Pacific region that are doing really interesting work, like Shuhui Fang from Hong Kong University, who's actually trying to identify individual contributions inside of these small group collaborations and the diversity of these types of contributions. But then we are also seeing the combinations of machine learning and epistemic network analysis to analyze some form of social ties. I'm going to be now returning back to the same example that I already had in some of the other representations where you saw the nurses and the nursing example. And you can see that this is now the schematics of it, that our nurses are typically asked to work around the primary task, which is one patient. In this case, this is bed number 4. And then primary task also involves the kind of use of the phone, so they can actually invite some other nurses to help them on that task. And then they can also see the secondary task. So that while we were actually working on this task, we wanted to use just the indoor location data to see the extent to which nurses are collaborating or working individually on either primary or secondary task, or the extent to which nurses were basically transitioning between tasks when they are basically on one task going to the other task, or when they are actually trying to distribute the tasks. You can see that they are not close to any of the two tasks, but there are two nurses next to each other. So we are actually trying here to make an inference that they are likely, and we also corroborated that by our observational data, that they are distributing the task. To do that, we actually then created 6 different variables that are precisely looking into these type of events in our data. The extent to which nurses are collaborating on the primary task or the secondary task, working individually on either of these two tasks, or spending time on a distribution or transition between different types of tasks. Then we use these type of features to train a predictive model that looked into the extent to which we could then predict students' performance on the task, whether they can successfully complete the task or not, or the extent to which they were effective collaborators during this particular task, where our performance measures were collected by asking teachers to assess the learners, or by completing a certain number of items that were assessing particular types of skills. As you can see that in certain types of situations, we can actually have relatively good accuracy overall, that is basically specifically predicting good collaboration, and the accuracy goes for almost 0.9 or 90% of the accuracy, while the task performance itself proved to be much harder, which is on the other hand, in a way, indirect thing, because we are using the proxies of the social ties, and these social ties eventually are supposed to be predicting performance, while the social ties are much more direct proxy of the collaboration itself, which in a way corroborates the meaningfulness of our results and why predicting the collaboration performance of the group is much more meaningful than predicting just the overall task accomplishment. The other important thing here is to think about is that not only are we interested to count the duration of the time people spend on some of these events or counting these type of events, but we are equally interested to build on something that David Schaefer calls epistemic frames. That is to say, we are interested to understand the overall, if you wish, the signature, how each of our teams are actually performing the tasks. That is to say, what certain types of these events that I was just introducing are potentially co-occurring. And to do that, then we constructed these so-called epistemic networks for both high and low performing teams. They were pretty much divided by the median value of the performance of the teams. And that is explaining us the extent to which they were performing better on the task, as well as performing better as on the collaboration metrics that we had in our case. And you can see here that the red lines are representing the connections that the low performing teams had, and the blue lines representing highly performing teams. You can see that the highly performing teams were primarily really working collaboratively on the primary tasks, and then they were also having strong connection with task distribution, and then also transitioning between the tasks. While the low performing teams were primarily emphasizing collaboration on the secondary task, and then also working on it also individually and collaboratively. And you can see that the epistemic network analysis is not only providing us these beautiful charts, but it's also providing us with these, you can see, solid rectangles that represent the centroids of these two groups. In a way, you can call them like the centers of gravity of these two groups. But then around them, you can see these dashed lines that represent the confidence intervals that can allow them to statistically compare the collaboration opportunities or the social ties of these two groups as they were performing. The other types of analytics that is used in many of these situations is really analytics of discourse. And in many of these situations, we are really interested to detect relevant indicators of collaboration. You can call that also coding. Often you come from a coding scheme. This is an example of a coding scheme we've been using in our research. And in our research, we were interested to understand the extent of, for example, a team has some form of shared leadership, have some form of situation awareness, shared mental models, and closed loop communication. And for each of these constructs, we were interested in particular behavioral indicators, as I was also previously talking about, the extent to which they were allocating tasks, provisioning of handover information, escalation of certain situation, sharing or requesting information or responding to requests, or acknowledgement of the receipt of certain information. So what we were really interested in this particular case is to not only collect the speech data, but we were also interested in real time to transcribe these type of data and then code each utterance automatically by some of these indicators, as I was talking about. So we are just basically completing one study, that is to say we have completed it and submitted it. And we were looking at the extent to which we can use automatic transcription services. Previously, we used Author AI. Some of you might have heard it, which proved not to be as good. And we actually were recently using Whisper, which comes also from OpenAI, and we were interested to understand the extent to which that could be reliable. And you can see here that we calculated certain types of error categories that are typically observed in these type of automatic transcription in these scenarios that I was talking about. And you can see that the crosstalk errors are most common, meaning while I'm recording a nurse that is speaking something, there is somebody else also speaking in the background because it's a collaborative task in a physical space that is not that small. Another one is also a common error is non-speech sound. error, meaning that basically something that is non-speech was recognized as a certain word or utterance. Then terminology is often also mistaken, especially because nurses are using very domain-specific terminology, or low volume error, contextual error, pronunciation errors, or language errors. On top of that, we also implemented a deep learning model that is built on a large language model. As well, in particular, we used the conversational BERT to get us the embeddings and then train a series of binary classifiers. And you can see that in most of situations, we received really very high levels of accuracy, except in a couple of situations that were actually a bit more challenging to provide us the like responding to the request, distinguishing it from some other situations, or provisioning or information sharing situations that in a way were to a certain extent conflating each other. And you can see also here, one important thing is when we are classifying these utterances, we are not using just that one utterance. What we are trying to establish the context of that utterance, meaning that we wanted to see the extent to which previous 1, 2, or 3 other utterances played the role in the classification or detection of these utterances. And you can see for different types of indicators, context size or that sliding window needs to be different. Final thing is when it comes down is to the analytics of the and the modeling of the collaboration with the multimodal data, is really thinking about combining multiple data streams. And I'm going to be just talking about one situation. You've seen that I actually modeled now the speech data and coded that data, right? You've seen also that we had the positioning data. Then the question is how I can then combine and what kind of analytics can I get if I'm combining these types of analytics. This is the schematic description of the combination of these type of data that we had earlier this year in a paper in which we proposed the so-called multimodal learning analytics, in which we are actually having these multimodal epistemic signatures of collaboration. And you can see that initially we would start from some audio or spatial data and do pre-processing of that data, and then try to identify discourse segments that could be actually then divided into particular physical spaces in which our nurses were doing particular tasks. And then we were also building upon relevant context-specific theories and fundamental teamwork theories to develop our coding scheme that you already have seen, and I presented that. And then we did coding of our data, and then eventually we generated our signatures. So when I'm talking about these signatures, really, we were looking into co-occurrence of the codes that were happening with respect to the particular locations of the primary or secondary tasks that we were interested in. So in a way, we wanted to understand if nurses are talking to another nurse who is close to them and who is working either on the primary or the secondary task or in transition, how they were actually performing that task and what were their differences in the epistemic frames. You can again see the two comparisons, or these are called subtraction networks, when it comes down to nurses working on the primary or the secondary tasks. You can see that the blue nurses were actually providing much more effective discourse as well. They were much more focused on provisioning of handover information, sharing information, responding to the request, etc. And that was primarily related to the primary tasks. While the learners who were lowly performing, they actually spent a lot of time planning. Sharing information was really just about planning. But when you see the secondary task, lowly performing nurses are dominating everything. They are just basically talking about everything else. So in a way, it just explains the extent to which they were really completely missing the point of being on the primary task and focusing on the primary task. Final dimension of learning analytics really is, once we have analyzed these type of data, how to get them into the hands of the educators, how we can then use these type of data to transform our practice and hence learning outcomes and the experience. we really need to consider this process that it's just not enough to provide some visualization to the stakeholders. It's really essential to think carefully how that data can be relevant. In some of our research, we are deeply engaged into the human-centered design principles, primarily aiming in long term to go into co-design, where our stakeholders are designing the types of analytics, but also, given that it's quite a challenging task, we work in participatory design, in which the researcher and the designer is actually offering certain solutions in which which are then evaluated intensely by the stakeholders. That's number one. Number two is also to think carefully as well, the extent to which our analytics really want to be in control of everything, meaning that we really want to make sure that human is in charge of the process. As Ben Schneiderman in his book as well posited, really how we can achieve highly reliable, safe, and trustworthy systems, human-centered AI systems, in our case, learning analytics systems as well, is that we want to have high level of human control by assuring also high degree of automation. And the final principle that we are suggesting for the development of multimodal learning analytics, if you wish, tools, is to think about data storytelling, meaning that humans, we usually do not just think about numbers when we are conveying certain insights. I'm even today trying to tell you the story and not just dumping the numbers of you. So the better, the simpler story we are trying to offer, the potential is for that message of the story is higher to be conveyed. To do that, our general framework, we call it HUSITA, which is basically a framework for human-centered embodied teamwork analytics, and really tries to think about the stakeholders who are providing certain types of inputs. They are basically often humans as sensors, meaning that they are collecting certain types of data. Also teamwork experts who are contributing certain types of methods and theories, and then also performance experts who are our task designers and educators. But thinking in terms of these type of sensors and the analysis, we are really synthesizing what I was already talking about. So first of all, we are actually trying to have clever ways to collect our sensors. Then we are using quantitative ethnographic team modeling, which is based on the epistemic network analysis that I was talking about, and then eventually expert-driven storytelling engines. They're producing the outputs that are potentially relevant for researchers, educational researchers, team science researchers, but most importantly, the actual humans. So I spoke a lot about certain types of principles and frameworks. I'm sure you want to see some of the results. This is the result, and it's still unnamed dashboard. It's actually being tested as of this week in practice. We are collecting these nursing data every year. We have about 300 nurses that are going through these simulations every year. They work in teams of 4, so you can do the math and divide 300 by 4, how many teams we have. We basically, over the years, designed these type of dashboards that basically have certain elements. First one is that our tool is actually having the information that is actually looking into different particular tasks that nurses need to complete during this particular task, during the entire simulation they are working on. So from the kind of handover, initial one, secondary nurses entering, doctors are entering, etc. And it's all visualized on a timeline. We then have communication networks. You can say these are social network analysis, who is talking to whom and for how long. Then we have these communication behaviors that are actually automatically coding the discourse of the nurses, and they're actually preparing these very simplified epistemic networks. Then we are also having these so-called word maps that are actually showing how and where the nurses were during the particular period of time. And then finally, we have certain prioritization bars as well that basically are indicating how each of the teams and even individuals in each particular team was doing particular types of things. We are using these types of dashboards now in practice. After each of the simulations is finished, nurses are going to talk then to their teachers to reflect and have a debrief on their performance. In a way, almost as a sports team is reflecting on their performance. And these visualizations are also integrated with the video that is the source that is used for lots of the type of data that we were using as part of it. What is really important to think about as part of this process is that visual data literacy can be a really big factor about the extent to which our analytics are effective or not. In the previous year, we had a much more simplified version where we tested some of these visualizations, and we were looking at the extent to which learners with high or low level of visualization literacy can correctly get certain information from some of these visualizations, and also the extent to which they can have timely completeness of that particular task. You can see that certain visualizations are actually offering much higher level of correctness. And although they look very fancy, like visualization 3 on this slide, they're actually not that easy for the participants to give you the correct answers. You can see also that the high visualization literacy learners are typically performing the tasks in a much more correct manner, but they take longer time, which or they take also shorter time as well, because that visualization literacy is allowing them to be much faster as they are doing things. While those who don't have visualization literacy sufficiently, it's becoming quite difficult for them. And that visualization literacy is not only important for students, but it's equally important for teachers. And we had one LUC paper earlier this year as well that talked about this particular thing. Final point I want to make in this is that we should really be very careful about identifying the pedagogical role of our visual analytics and the tools that we are building based on learning analytics. As I indicated, in our scenario, it's a very clear thing that nurses are, and this is one of the nurses from last year, so this is not the this year dashboard that I showed, but this was basically what nurses were using last year upon completion, and the head nurse was pretty much sitting with the in-training nurses who were actually then discussing how they were utilizing the space, how they were communicating with each other, and how they can improve next time. All right, I'm coming to the end of my talk. So obviously, complexity inherently drives lots of needs for collection of different data sources to understand and analyze collaboration. But really, if we are thinking about the boosting the impact, the key point is to think about the transformation to use analytics with a very clear pedagogical purpose. Thanks so much for your attention, and I look forward to your questions.
Thank you, Professor Gasiewicz, for the wonderful story about collaborative analytics. And you started with data collection and understanding learners' collaboration and cognition in collaboration, then showing a dashboard to the learners. So I request the participants to post their questions. Due to time concern, we'll take maximum 5 questions. So while the participants, I have a couple of questions. When you talked about, instead of looking at utterances as a single logical sentence, you were saying that I will be looking at the last 2 or 3 utterances together to imply the context to the system, in the conversation bird. So what is how do we consider the number 3, the sliding windows size is 3 or 2? And you said that this varies depends upon the different factors we have considered. Yeah. So
no, it's a really good question, Ram. At this stage, we are basically considering that empirically. We're just basically, in our study, we basically looked between like just a single utterance to do like that sliding window of 6 or 7. I don't think we can really easily determine theoretically what is that window. I think in certain situations, it makes sense to be just window 1. But in many cases, you really need to think about what is the kind of the optimal window by empirically looking into different situations where it works best. And I think that's really what we are seeing also from others who are involved into quantitative ethnography, like David Schaefer. They would typically go into these sliding windows in the range between 3 to 6, but most of their studies were in the environments in which participants had a computer-mediated communication in the form of a chat.
Great. We have one question from Ritayan Mitra. You talked about role of task design in studying collaborative analytics. Can you offer some suggestions on what to keep in mind when designing such tasks?
It's a terrific question. It's a really important thing to consider that. I think, look, in learning analytics, we should not be reinventing the wheel. Literature on assessment, literature on intelligent Turing systems is quite rich. Also, when it comes down to the task design, literature on collaborative support, computer support, collaborative learning is also quite rich in that sense. So the key thing is, though, when we are coming to learning analytics, which is common also with the assessment literature, is that you really want to see what is my first objective of this collaboration, what kind of skills I want my learners to develop during this process. And by that extension, what kind of skills I want my learners to exhibit. If you are then interested in exhibiting these type of skills, then you need to see, okay, what kind of scaffolds in that collaboration or the task design I need to embed so that learners can demonstrate, for example, critical thinking, or they can demonstrate that they are actually talking to each other, they are negotiating, or they are having effective distribution of the tasks, and so on. So it's really much more talking about the task itself, but when it comes down to the learning analytics, it's also thinking about the extent to which learners are going to be motivated or guided by the task to externalize certain type of things. And or can you actually use certain sensors as well, even if the learners are not explicitly externalizing that by their speech, they are externalizing that by their movement, position, and so on. That is quite effective there. I'm not sure whether I answer a question, but I think at least gives the direction in which I'm thinking about this whole endeavor.
Yeah, I think you answered it, Logan. So the next question is about how can we represent the codes from discourse analytics occurring simultaneously by different teams as a time series graph? Like that 2-3 teams are working. Can we represent them as a time series graph? Is there any?
It's a really good question. I'm not an expert on time series graphs, so I cannot give you really a precise question on that answer. My probably time series graphs can be done in that way. Most of our work is really trying to understand what's going on with the other types of representations, such as epistemic network analysis. I'm sure our epistemic network analysis can be also represented with graph neural networks, and that can be also used for other types of analysis. But I have to basically apologize that I'm not an expert in the time series graphs.
So the next question is from Yiming Liu. When transcribing the team, so you mentioned crosstalk as highest tier in the Whisper, right? So could you recommend some software or language models to do the crosstalks?
Look, I mean, our results compare. We basically, I think up until a year ago, Otter AI was the state of the art speech recognition software for transcription. We analyzed it, compared. We did really empirically, like that I can cite the statistics between these two, but we just did a relatively quick comparison between two. Whisper that comes from OpenAI is, I think, the state of the art that you can use for automatic transcription that can be also used in real time. So that would be my recommendation.
Okay. So there are a couple of questions about the lab study, like what inferences one can draw from location of participants, in this case, nurses. So I think you have shown about the 4 different beds, and the nurse can be in different location during their training period. So, yeah, what is inference?
Yeah, so what we are inferring here, the extent to which, based on location, we are inferring whether the nurse, we can infer, first of all, who is talking to who, right? Based on the proximity of the individuals, we can just simply derive these social ties. Also, we can make the inferences about whether learners are working together on the primary or secondary tasks, or they are working just individually. Those are basically very quick type of information that we can derive. We can also derive, based on this type of information, the extent to which they are effectively using the space. We have a new analysis that are showing that basically nurses who are lowly performing these tasks are actually walking much more. So at least in the culture I'm coming from, basically we would have this saying like those who don't have so much in their head, they actually had much more in their feet. So in a way that is also proving that kind of saying as well. But in a way that kind of is giving us the inference as well, that is kind of offering us about the efficacy of the certain team and the level of the coordination of that entire team.
Yeah, so thank you. The next question, I think from Yanji Song. Many thanks for great talk, which represents many new ways of collaborative analytics. Very impressive. My question is, how can you explain more about embodied teamwork related theories?
With respect to the theories, that's a really, really interesting thing to think about that. I need to be here making a confession. I'm not necessarily a theorist. I'm a computer scientist. My suggestion with respect to that is that we definitely can build some of the new theories that are more kind of emerging ones. As you can see, that we can get really relevant operationalizations of the relevant elements of the social cognitive dimensions, and we can also get that in a much more dynamic manner. We can also do these type of explanations as well in a much more longitudinal manner as well, and it becomes much less expensive. So rather than talking from my end about the particular theoretical constructs that you might be interested in to theorize collaborative learning, I'm going to be talking much more methodologically, that based on these type of analytics, not only can you inform and build theory, but you can also much faster test certain ideas and then move much quicker into the validation of your theoretical claims.
Okay, I think I have a last question for you. This is a transforming question. So can we use collaborative learning analytics in teacher education as well? If yes, can you give us ideas?
No, absolutely. Oh, that's a terrific question. Thanks so much. So if you remember the example that I was talking about in schools, in which we were just using the sensor data, so not only do we use this sensor data in that particular case to understand how space is used, but our primary also intention in that space was to think about how we can improve teachers' skills, how they can utilize the space, how teachers can improve the way how learners are collaborating with each other, how they can improve their pedagogies, etc. So the ultimate goal there is similar, is to produce similar type of dashboard or user interface or analytics for the teachers so that they can reflect on their practice, to think about their practice, how they can innovate their practice, and how they can think many different ways. There are also some of the other people around the world that are trying to push the collaboration as well, and especially in the classrooms, between human and AI collaboration, but also the role of AI in the classroom, like Sidney DeMello's NSF-funded AI Institute for Human AI Teaming, in which they are also looking at the extent to which they can capture these like nuanced discussions, chats, and everything else that is happening in a physical classroom between the learners. I think the jury is out there, though, the extent to which we can easily analyze these collaborations in the actual classrooms with the kids versus these type of very specific types of scenarios I was talking about, such as simulation-based learning, which has in a way bit more controlled environment in which you can actually collect much better quality data, and in which you are not going to endanger the privacy of the learners so much as you would do it in a regular physical classroom, and equally so privacy and agency of the teachers in their physical space. So that's the answer.
Thanks, Professor Gasavesh, for a wonderful talk and answering all the questions. Thank you, all the participants. And I request Mr. Tao to share the thank you slide.
Yeah, we'll say shared.
So I request everyone, all the participants, to go through the feedback form, and request you to fill the feedback form, the web survey. You can scan using QR code or type in news.apsce.net. Thank you, everyone, for participating. Thanks, Professor Gasavesh, again.
Thank you.